Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with some of the questions on regression correlation coefficient, and we'll be doing just the PYQs and some tricks how to solve them quickly in the examination. Those who have already done this topic can watch this video in 1x time and stop at the question and solve it on your own and see whether the answer is correct or whether you're taking more time than me in solving, or if not, then you can take the tricks from here. And those who haven't done it yet, then they can rewatch my lecture videos on correlation coefficient from the playlist, and then they can come back here for the practicing of the questions. So, before starting the question, let us first recall what the concept was. So, if we talk about correlation coefficient, this is denoted by R. And if we are talking about two variables x and y, then correlation coefficient between x and y, it has the formula covariance between x and y upon standard deviation of x into standard deviation of y, or we can write variance of x into variance of y under root. Okay, here the value of rxy will float between -1 and 1, and this term is very important for your examination point of view, because sometimes they ask directly that what are the limits of correlation coefficient. Then only you if you only you know, then only you can solve that question, otherwise that will be loss of your marks. So this was the basic concept on correlation coefficient. Any more concept that will arrive along with the question, we'll be dealing with that then and there. So let us begin with our first question. This is the first question which was asked in 2019 of your examination. In this question, they have given us the correlation coefficient between x and y, which is rxy as 0.6. The covariance between x and y is 4.8, and if the variance of x, they have given us the variance of x, which is 9. Now, since I am teaching you, I have to write all of them, and first of all we'll be doing it in the very detail, and then I'll tell you how to do it with tricks. Okay, so first of all, the correlation coefficient has the value rxy covariance of x comma y upon under root of sigma x square into sigma y square. So putting the values here, we'll be getting rxy 0.6 equals to 4.8 upon under root of -3 into sigma y. Now replacing the values, we'll be getting sigma y equals to 1.6 upon 0.6, which is 8 upon 3, which is nothing but almost equal to 2.66667, and which forms our answer, option number D. Now, how to do it quickly? Instead of writing all of them in the examination, just put the formula, put the values in the formula. If you know the formula, then you don't have to write it again and again. So, if we have to find standard deviation of y, then it is nothing but covariance between x and y, which is 4.8 upon the correlation coefficient into the standard deviation of x, and after crossing them it will be 16 upon 3. Now 16 upon 6. Now since the denominator is 3, only the values 333 and 6667 can only come in the points afterwards. So only one value is there, which is 67. Otherwise there's star 2 3, which cannot be the case. 2 1 also cannot be the case. 3 2 cannot be the case. Either it is 3333 or it is 6666, or for the point they do it 67. So these two values can come when the denominator is a multiple of 3 and only one value is there, 2.67, then we can mark this as our answer. Okay, this was our first question. Now let us move to another question. Here they have given us that x and y are the random variable with finite variance sigma square. So the variance of x, or we can write sigma x square is equals to sigma y square is equals to sigma square. They have given this to us, and they have given us the value of y is equals to 20 minus x. Now then the correlation coefficient between x and y. First of all, we have to calculate the covariance between x and y. X, x plus y, and x. This we have to calculate. Now from here we can say that x plus y is nothing but 20. So here we can write covariance between x and 20x. Now this can be, covariance has the formula variance of x, this is 20 into variance of x, which is nothing but 20 sigma square. Right? Now we just have to put the formula in the question, which is we have to find the correlation between correlation coefficient. So Rxy will be covariance of R x x x plus y is equals to covariance between these two terms, which is 20 sigma square, and under root of sigma square into sigma square, which will be 20 sigma square upon sigma square, and answer will be 20, which is our option number C. And the variance of this term will be 20 sigma square, so it will be under root of 20 square sigma square, which will be 20 sigma square, and our answer will be 1. So the correlation coefficient between all of them is 1, the two variables. So the trick here that we'll use is, first of all, we have to calculate this. This we can't get rid of. We have to calculate this. Then the second thing, without writing all of them, we just write the covariance between both of them is 20 sigma square, or variance of x is sigma square. That will be under root of sigma square. And variance of x, x plus y will be equal to 20 square sigma square, because it is variance of x, x plus y. We can write this as variance of 20x. Now the constant will come outside, which will be 20 square variance of x, and variance of x is nothing but sigma square from here. So it will be 20 sigma square. Then we can directly keep this under root 20 sigma square, 20 square sigma square here. This sigma square get cancelled with this. This 20 square will get cancelled with this, and we'll get 1 as the answer. Without doing all of them, we can just write it in this much space and get our answer. Now the next question. Here they have given us that R is the correlation coefficient between two random variables x and y. If z is equals to, so R is the correlation coefficient between x and y, and z is equals to ay plus b, where a is not equals to 0 and b are real numbers. Then the correlation coefficient between x and z. So covariance between x and z, which is equals to covariance between a y plus b into x. Now the covariance between a y plus b will be covariance of x y into a. Now we just have to find R, X, Z, which is covariance between both of them, which is A into covariance between X and Y upon under root of variance of X, which is sigma X square, and under root of variance of Z, which is sigma Y square. Now here they have given us that R X Y is R is equals to covariance between X and Y upon under root of sigma square into sigma square, which is we can transform here in it is under root of this. Under root of this can be given as A upon modulus of A into covariance upon X and Y, sigma square into sigma square will be 1 of sigma Z square. So 1 upon R into R. This is the direct implementation of a theorem. So whenever there is a random variable, three random variables, and one is two are related and one is giving aloof, then the formula is always this D, A upon modulus of A into R, which is option number D. This is the theorem, we have to do it directly. Now here in this question, they have given that D is equals to X minus Y, and standard deviation of X is equals to standard deviation of Y. First of all, let us calculate variance of D. Variance of D is equals to variance of X plus variance of Y minus 2 covariance of X comma Y, right? This is the standard deviation, but they have given us standard deviation whole square, which is nothing but the variance of D is equals to variance of X plus variance of Y. But this term is not present. So we can say that covariance between X and Y is equals to 0 because this term is not present. So what is the correlation coefficient? Now correlation coefficient is nothing but covariance between X and Y upon sigma X and sigma Y. But the covariance is only 0, so this R correlation coefficient will be equal to 0 only, which is option number C. Now this is the case where when correlation coefficient is 0, then we can say that X and Y, if X and Y are independent, then we can say that the correlation coefficient is 0. And if the correlation coefficient is 0, it is not necessary that X and Y would be independent. So that should also be kept in mind while doing these kind of questions. So it has the answer option number C equal to 0. Now, the last question for today's class is this is the question from 2017. They have given us that all the variables x1, x2, x3, and x4 are uncorrelated variables with variances sigma square. So, variance of x1 is equals to variance of x2 is equals to variance of x3 is equals to variance of x4 is equals to sigma square. Then they have asked us to find the correlation coefficient between u and v. So first of all, we have to find out variance of u. Variance of u is variance of x1 plus x2 plus x3, and since they are uncorrelated, so covariance will become 0, so it will be 3 sigma square. And similarly, variance of v will be variance of v1 plus variance of v2 x2 plus variance of x4, and covariance term will be 0, so hence it will be also 3x square, 3 sigma square, sorry. And now the covariance between u and v. So u and v has the common term x1 and x2. X3 and x4 are not common in both of them, so covariance between both of them is variance of x1 plus variance of x2, which is equals to 2 sigma square. Now we just have to put them in the value. So R U V is equals to covariance between them is 2 sigma square upon under root of 3 sigma square into 3 sigma square, which is 2 sigma square upon 3 sigma square, which is 2 by 3, which is our option number C in this case. Okay. That's how you solve these kind of question. It will require, if you do all these calculation in mind, if you have practiced enough and you do all this calculation in mind, then you can solve it within seconds for your examination, and you don't have to copy the whole concept and then see and then do. That is for the layman who doesn't know how to solve them. And those who are preparing for the next year's examination, it is okay if you're solving like that, because in the beginning it is compulsory that you see and solve, and as and when you practice, then you will become perfect. So, for the ones who are preparing for this year's examination, it is not even a month left. So these are the classes mainly concerned for you all, and those who are preparing for 2027. I would like you all to know that we have recently launched our Lakshya 2027 batch, in which we'll be having all of you who are interested in 2027. We'll be having limited number of seats for, and there will be one-to-one interaction with every student. We take every student as serious as they are according to their ISS strategy and preparation journey. So hurry up and enroll now for our Lakshya 2027. And those who have doubt in today's class, they can leave the comment down below, and I will solve their doubt as and when as soon as possible. So all the best and thank you.
Welcome to StatUp Academy, India's exclusive coaching for ISS, where statistics meets excellence. StatUp Academy,